So the quick agenda is we're going to talk about why we went through the trouble of making this, what exactly it is, how to use it, and what the implementation looks like, and then I build this plugin framework for us.
So this is this is the two things we did. We did a plugin framework, and we did a plugin based on LevelDB. The plugin framework is we didn't start from scratch because earlier Ulf Wieger had done some experimental work with a framework as a backend to Mnesia to plug in new backends. Okay. So why did we choose LevelDB? We mainly thought that it was a trustworthy choice, one of several, and we also, because Basho use it in React, and seemed to be well tested, and then there is a well tested Erlang binding from Basho also, and this interface maps very well to Erlang, to Mnesia, because it's a key value store. So what is LevelDB? LevelDB is a library from Google for a key value store. It implements a set, and it stores everything on disk ordered, sorted. So it implements an ordered set. There are some optimizations. It can support prefix searches. So if you have the first part of the key is fixed, it's much faster. You only have to look through that part of the disk that starts with that key prefixed.
For starters, getting it going was really easy. You just call this register function, and then we already have kind of a framework for anytime you make a change to a table in Mnesia, it propagates those out to your tables immediately, but just on the next restart, or you can. So I just had to change a few places which specified the table type and switch it to the LevelDB table type. And then you can just use your standard Mnesia functions as you expect, which is really the most important part and most useful part. So even if like the performance is a little bit worse, the major values, you don't have to do anything to get all of these other benefits of startup time, if that's what it gives you. So for initial testing, I just did we have a common test suite. It takes a reasonable amount of time to run, but it just sort of tells you that everything you expect to work actually did work. And then once we got through that, we used Basho bench using live data. We can just pump our logs through it and check the output to make sure it's the same, or make sure that there's no new errors and stuff like that. So we started with a subset of the data, and then we migrated almost all of our data over for real live big test. And so the experience, the good parts are the application from our testing responded the same. The performance had the same profile, same basic characteristics. It wasn't slower by any usable, measurable way. Our first attempt reduced startup time by 1/4. And that doesn't sound like much, but the main problem is we have this really big bag table that takes forever to start up. And we're working on migrating that. And once that's gone, we're pretty sure we'll get either, pretty confident we'll get half startup time or better. And yeah, so having lots of data in bags is not a good idea. It's just, it'll ruin your day. And also importantly, we reduced our startup memory by 2/3, because LevelDB does this caching layer. And once you start actually running requests through and doing gets and all that, the cache fills up, so you can end up using up more RAM, but it doesn't have to load much of it at all when you first start, which is really nice. So it does the loading stuff. And then the migration was really, really easy. Like I said, all I have to do is change the table type, and then the plugin framework handles bring you into that new table type that the plugin represents. And it's also really nice for testing because you can have machines with a lot less resources for all your testing, and then when you actually want to do a real test, you just bring it up on your real hardware and then see what works. But with a smaller data set, I was able to get that down to about half the size. Well, much smaller, so I could just run it on a desktop, which is really nice. Now, the not so good, like anything, this is, as far as I know, which better be true, is we're the only one using this right now, which means it's completely unproven. So far, it's been really stable for us, though, but we haven't really tried to push a lot of data through it. We've mostly just been doing performance testing here and there. So it could be unstable in ways we don't know. And implementing a plugin is a bit messy, but this is just sort of getting changes into the Mnesia code that exists. Mnesia code is somewhat messy in places, so you have to kind of make a decision whether you want to have something that performs well, or you really want purity there, and performance for your data store seems like the good trade-off. The other problem is LevelDB has terrible read times on deleted keys. For the initial, on our common test suite, each test will add a bunch of data, then delete it at the end, and then reread those keys later on in another test, something like that. And our common test suite ran about 30x slower, and it took a long time to figure out why, and it turned out because the first one ran normal speed, and then the next, it deleted all its keys, and the next one kept running slower, and so on. So apparently this is fixed in the current version of LevelDB, which we aren't using, but we fixed it by, instead of actually deleting things, we wrap every single entry up that we store in a tuple that has like an active true or false on it, and then a delete is just saying active to false. Migrating out of LevelDB is not so easy. You can't just do a change copy type. You have to actually copy everything to another table, make sure it's correct, and then delete the old table and then rename it. And that's not super hard or anything like that, but it certainly is something to be concerned about if you are moving to one of these plugins. And the LevelDB raw speed is a little bit less than DETS, but for how we use the data store, that's not that big of a deal. But it's robust though, so you get the same slowness every single time. And if any of you have seen the Keep video from about them scaling React, they talk about LevelDB. The idea is there's levels on your data store, and the more data you get in there, the more levels you add, and each level is another directory point. And they talk about how each time they got more data in there, a level went up, and then that added about 15 microseconds or something to their latency. And we did not experience that, mainly I think because they're running on EC2 and we're running on real hardware, so we don't have the I/O ops issues that they do on EC2. But we didn't notice any issue with the LevelDB, the way it stores data. And then just some little caveats. Searching a key that starts with a wildcard, it will iterate your entire table space, your key space in it. And it is possible that iterating a whole table might destroy your LevelDB cache. So if you do that on the live system, for example, you could be running very slow for a little while until that reheats. So I would suggest against doing that. And some of the semantics were changed for Mnesia on this. So for example, if you want to get all the nodes that have a certain copy type, you do table info and the name of the table and then the copy type you're interested in. And if you create that table before you added this plugin, your LevelDB copy type won't exist and your table info call will fail. Don't think I can say, but very big.
So there is also an option on eleveldb to actually prevent it from blowing out the cache.
Yep.
So
Well, so it depends on your how you choose to iterate the table, and that's not an option that we can use because you either have to, it's either on or off all the time because the Mnesia interface itself doesn't have a way to say when I want to iterate this, pass these options to the backend to decide how to iterate it. So you're stuck with either it being on all the time or off all the time.
is that something that you could build into the plugin framework?
I don't think so. Roland might have a better idea, but the interface itself is defined by Mnesia, and you're kind of, the plugin framework is way below that, so you don't really have a good place to pass that information.
I didn't hear the question.
Well, I was just thinking about I helped, my name's Dizzy, I helped write the eleveldb stuff, and
Yes, I know.
not being able to pass that option in, you could see much better performance if you could pass options in when you do the iteration.
Oh, okay.
So if that's not in the plugin framework, it might be useful to add it.
It isn't. No.
Anything else? All right. Thank you very much.